Danielle Restelli is an awesome trained geologist, gone engineer and environmental scientist who is completing her master's at UH. And she worked as a engineer for local compliance companies and large environmental science companies. And now she's working under my former advisor, Dr. Babcock at UH Manoa. And feel free to add anything that I forgot, Danny, but I'll hand it over to you.
Thank you. That is a great introduction. It's nice to be here. Thank you guys for having me. I will be talking about Ridge-to-Reefs Bioreactor Garden. So let me just share my screen real quick. Wait, sorry.
And he's also been an excellent partner to WAI in helping us monitor this project, and is in the process of writing a report about it. And is there a prize for the closest guess? Alani offers. Yes, if you look under your chair, Palani, there is a free bioreactor garden certificate. One lucky person on this call will find that. And we also have Councilmember Rebecca Villegas just joined us, and Terry Hall. Welcome. You're just in time. We're starting the presentation now. Back to you, Danny.
Oh, sorry, we're in presentation mode. Let's get out of that.
There we go. You got it.
Oh. Okay, hold on a minute. There we go. Okay, I just want to do.
This is not Danny's fault. We had promised her we could give her 10 minutes to test out the tech, but we didn't get the Zoom links in order, so it's not her fault.
Oh, thanks for sharing that. Let's just, does this work just a portion of the screen?
There you go.
Yeah,
Perfect.
nice.
All right, we just see the slides now?
Yeah.
Okay, thank you guys for waiting. My name is Danielle, if we've forgotten. I am a graduate student in the Civil and Environmental Engineering Department at the University of Hawaii, as Yoko shared. Today, I'll be presenting my research and the results of the performance evaluation of our constructed wetland type on-site wastewater treatment system. This will be for cesspool replacement in Hawaii. I also want to just thank you guys again for having me, and Ridge-to-Reefs for their awesome innovative design, as well as the Water Resource Research Center. So just an overview. First, I'm going to start with an introduction to wetlands and their characteristics, as well as present Ridge-to-Reefs Bioreactor Garden. I'll review NSF 40 and 245 test protocols, the results of a 26-week pilot study. I will discuss our effluent quality and compare it to other systems we've tested alongside it, like the aerobic treatment unit, and then review and discuss some of our ongoing efforts for additional data on the bioreactor garden. So we are not done yet. So as many of you know, Act 125 Hawaii legislature requires us to replace all 88,000 cesspools by 2050. That's not news to us. Cesspools lead to contamination and are of high risk to public health and water resources. Septic tanks are an alternative, but they provide only minimal additional treatment of wastewater. So constructed wetlands are a great alternative. They are affordable, they don't require electricity, they have a small carbon footprint, and they remove nutrients like nitrogen, phosphorus, pharmaceutical compounds, all of which are very harmful to the surrounding environment. So as promised, an introduction to wetlands and their internal characteristics. When vegetation in a wetland dies, it deposits carbon to the sediments, which microbial activities depend on. It also absorbs carbon from the environment through photosynthesis. The proximity of oxic and anoxic zones in a wetland are created by plant roots. We see in this zone here, and they allow for simultaneous activity of aerobic and anaerobic microorganisms. So overall, wetlands are characterized by periodic and permanently saturated soil conditions, a steep gradient in soil redox conditions, and all of these characteristics contribute to their capacity to cycle biogeochemical elements. There are multiple types of wetlands. So today we'll be discussing the constructed wetland, but you've all heard of marshes and river wetlands, and there's many other types as well. So on the right, we have the schematic diagram of Ridge-to-Reefs Bioreactor Garden at the East Honolulu Wastewater Treatment Plant. This was for our pilot study. Here you can see the raw sewage channel where we collect influent. It is raw, but it is screened influent. And this bucket up here is used to control the influent to 600 gallons per day. And then we have a 1,000-gallon septic tank, which allows for solid liquid separation prior to entering the bioreactor garden. Then on the left, we have a design drawing of Ridge-to-Reefs Bioreactor Garden. It has a coarse layer on the top here to cover the pipes, a 20-inch sand layer, an 18-inch wood chip layer, which is the anoxic zone, which allows for denitrifying capabilities of this wetland. Here are some photos of the system. This is near the beginning when we first brought the system online. And over here is near the end of the system. You can see we've got some long, beautiful vetiver grass. And in the back over here, there is a big green tank that is an aerobic treatment unit that was tested alongside this system. So we had the same influent going to both systems, and it was good for comparison. It's also built for nitrogen removal, so we could compare data very well, and it was using the same test protocols. All right, I'll just start with reviewing the National Sanitation Foundation test protocols. This is for NSF 40 and NSF 245 certification. They call for testing the system at its rated daily flow capacity, which is 600 gallons. It specifies a discontinuous flow pattern in which different percentages of the flow go in throughout the day. So 35% in the morning, 25% afternoon, and 40 in the evening. Following the design loading period, which is 16 weeks, we have a period which is called the stress loading period. So there's 4 total stress tests, and they're designed to evaluate the actual performance of the unit under real world conditions. So we simulate high or low loads, and we see how the treatment processes respond. I won't go too into depth, but the first one's a wash load. We have a 36-gallon wash with detergent, non-chlorine bleach, and that happens 3 times during this first week, and that's followed by a 9-day stress test recovery. The second stress test is a modified daily flow pattern in which there's no flow to the system between 9 and 5, and there's a higher flow in the morning, 40%, and in the evening, 60%. This week, we also did 5 wash loads between 5 and 8, and this was followed by a stress test recovery as well. The third stress test is the power equipment failure. So this one is designed more for an ATU because a constructed wetland requires no power. So we were basically seeing the high flow load, the 60%, and the wash load, how those affect the system because the constructed wetland is immune to power failure. Then the last stress test is a vacation, which is 1 week, 8 days with no flow, and then the shock load that follows that, which was 3 wash loads in 3 hours. And that was the last stress test. So we followed that with 18 days of the design loading. All right. Table 2 shows the analytical methods and the analytes tested. We collected samples, composited 5 times a week using an automatic sampling device, and the results from those samples are compared to these criteria here for NSF 40 and NSF 245. So we've got monthly averages, weekly averages, odor, oily film, foam, color, total nitrogen has to be less than 50% during that design loading period. So that's that first 16 weeks. And the pH needs to be between 6 and 9. All these have to be met in order to receive the certification. All right, here are some results. This is the carbonaceous BOD5 and the total suspended solids for the entire test period from February to August. As we can see, this period here is a stress load period. What's awesome about the bioreactor garden is that it doesn't experience high spikes in this period. We don't see really low lows, so it does well during the stress tests. Here we have the 30-day averages and the 7-day averages. So the red lines are the max TSS for the requirements, and the blue line is the max CBOD to meet the requirements. As well, you can tell that we do well in the stress test zone. The effluent TSS over the whole testing period was 6 milligrams per liter, and carbonaceous BOD over the testing period was 19 milligrams per liter. So this diagram shows that we met TSS and CBOD requirements. Next, we have our nitrogen data. So denitrification is a process that reduces nitrate to nitrogen gas in an anoxic environment. So you'll see here the circles. This is our effluent total nitrogen. These diamonds, this line is our total Kjeldahl nitrogen, our influent nitrogen, and the green line is the removal efficiency. So in order to reach the NSF 245 requirement, we have to have above 50, this line here, for the first 16 weeks. But as you can see, the whole time we were well above the 50%, and the overall was 85% actually. So here's a comparison of the effluent quality to the criteria. We've got our monthly averages for CBOD here, our monthly averages for TSS here. The gray is just the time period during the stress test, so we can kind of see that they fit in well with the rest of the data. There's not big spikes there during those months. This maximum of 32 was the highest 7-day average we had for CBOD. And this 18 is the max TSS we had for our 7-day averages. Our pH was between 7.1 and 8.5. There were no offensive odors, no oily films, no foam. We measure color, but there's not a criteria for that. So the total nitrogen, like I said, 85% during the 16-week design period. So that meets our NSF 245 criteria. And here we have the removal rates. So I wanted to compare those to an ATU because a lot of people are familiar with ATUs. We have the one tested in 2021 alongside this one, and one tested in 2016, also by the Water Resource Research Center at Hawaii. So our total nitrogen removal was the highest of the three, which is really awesome to see. The BOD removal, a little bit lower, still meets all the requirements for NSF 40. And then the TSS removal kind of fits in well with this data as well. All right, to conclude, the bioreactor garden from Ridge to Reef met all the requirements for NSF 40 and NSF 245. It was comparable with an ATU tested alongside it for effluent quality, and it even had a lower impact from stress tests than the ATU did. It uses zero energy, there was no vegetative maintenance required, and we believe it's a viable option for cesspool conversions in Hawaii. So we are continuing to work on this and gather more data. Right now, we're looking at effluent flow volumes to determine evapotranspiration rates, to see, how much effluent is absorbed into the roots and into the plants, as well as looking into carbon sequestration from the vegetation. We have an option to use biochar, so that's something Ridge-to-Reefs is looking into. And then we're also comparing energy costs from the ATUs to the bioreactor garden and construction and operation costs. And lastly, they are looking into the potential use of recycled materials in possibly like this liner, some of the wood. So if it could also be from recycled materials, that would be great. All right, and that is all I have to share today. I wanted to give a special thanks to Ridge to Reef and Water Resource Research Center, and Vi for having me today. If you have any questions, I will be here and ready to take them. Yes, Stuart, did you have a question?
No, that was just a clapping emoji. So for good job.
Okay,
Yeah,
you're
thank
also
you.
welcome to email me if you think of something later that you want to ask.
Yeah, perfect. Thank you. We really couldn't have done it without you, Danny. You were going out to our pilot site at the East Honolulu wastewater treatment plant. How many days a week?
We did 5 days a week, but I had
5 days a week. Yeah, so it's put in a lot of time and effort into this. So we really appreciate it. But let's open it up for questions now. You can either kind of raise your hand and ask them in person. It looks like Ted has a question, or put them in the chat. But we'll start with Ted.
Thank you, Stuart. Thank you, Danielle. My question is whether you have made any presentations to the Department of Health Wastewater Branch or the Cesspool Conversion Working Group of all of your findings. And if not, Stuart, when are we going to get them in there?
Yeah.
We have not presented to anybody but you guys, and we're working on a report that will go to Department of Health, and that's how we get certified for the NSF 40 and 245.
Great.
That's a great suggestion. I think we should follow up with the cesspool conversion working group, Ted. So maybe, yeah, you and I can follow up and suggest that we do this presentation. Yeah. Thank you. Ted and I are members of that group, and that's winding down after 3 years. Other questions? Martha has asked, any idea of the cost per garden?
That would be a good question for Paul, I think.
Yeah, Paul, do you want to chime in? It depends on size of how many bedrooms and such.
I think so the supplies and materials are relatively inexpensive, say less than $5,000, and that probably also includes the septic tank. And a lot of the materials we use, like the wood chips, were made from invasive species that were cut down. We used a local source of, I'm trying to remember the name of the media, but basically, we locally sourced the materials. We used native plants. We used vetiver grass, which is a sterile grass. So all available kind of locally. And so that was one of the goals too, is that we're trying to keep the cost low. We will be building one of these in Oahu at Christina's house. So we will be upgrading her cesspool, so to speak, or replacing her cesspool. And so we'll have a better understanding of costs after that. Because really, I think labor and material, or labor and construction are, the two biggest costs. And I think we have some idea of those costs, but really, I think the proof is in the pudding when we actually put one in the ground and can kind of, parameterize that basically.
Yeah. I told you that one lucky person on this call would get a free bioreactor garden. So true to our word, Christina will be doing that. And as a water quality specialist, she'll also be monitoring the effluent after it comes out of that. So this will give us, further information, as Paul said, about costs and such when we start doing these. And as I mentioned in the chat, we got a USDA technical assistance and training grant to do more of these and to teach people how to do them. So let us know if you're interested in that. Our next question comes from Polani, who says, very cool. Did you study harmful bacteria levels in the soil versus a control site dirt nearby, i.e. dirt nearby?
We did not. This would be the imported sand and imported wood chips. So I know that they're very careful about the criteria for what was imported, but that is something we could be looking into in the future.
And just, yeah, go ahead.
A quick, people have People have studied denitrifying bioreactors in the past and their ability to reduce bacteria. And because it's an anoxic system, they're pretty effective at removing bacteria.
And yeah, there will usually be some, brought in. They can, Paul, recycle some of the dirt when they excavate, but then you'll also be bringing in, certain level quality sand, certified sand, and then wood chips and biochar and such. Yeah.
And normally, like to go off of Polani's follow-up question, if a kid were to go digging around in there, could they potentially get sick? So normally after the wastewater goes to the septic tank, it would just go to a leach field in the yard. So in this situation, there would be, before it goes to a leach field, there's this garden that is processing out some of the nitrates, and there's microbial activity going on in there, but it's not any more toxic than what would be found in the leach field normally. It's actually going to end up then having the leach field be cleaner. And the garden, where the garden is, would be the same water that would normally be in your standard septic system leach field. Does that make sense?
Yeah.
Or help answer that question?
Yeah, thank you. And Martha asked about permitting. So I don't know if Yoko wants to take that one.
Yeah,
Or-
Danny, do you mind?
Go ahead.
Yeah, so this report that Danny is now finalizing is the way to get this permitting possible. Essentially, the Department of Health says anything that's National Sanitation Foundation 40 or 245 certified goes. And they trust that nationwide certification, and they trust University of Hawaii to conduct the state equivalent of that. So once the Department of Health has accepted it, it'll be permitted just like any aerobic treatment unit.
I also saw a question about the lifespan of wood chips, and so the lifespan of wood chips, or the half-life of wood chips, is around 35 years. So and even just with half the material still there, and that's assuming also under anoxic conditions, wood chips break down even slower than that. So yeah, we don't think that that's necessarily a concern in terms of the total lifespan of these practices. And there's also a tremendous there's an overabundance of carbon by using the wood chips, which the carbon is the food source essentially for the denitrifying bacteria that are doing the work. Another question is about the water underneath, and potentially if a kid was digging in there. The water should be around 20 inches below the surface. But there is potentially, when the system is being dosed, essentially, there will be water or there will be effluent or influent going in to the system. But we don't expect that to, hang around very long. And we're also, I think part of the idea is to put that under some gravel, but I think that certainly is a concern, and I think it's part of the sort of the educational, the educational process around this practice. One reason I'm not always comfortable having it, calling it like a typical wetland system, because most wetlands, have water at the surface, and this one should very rarely, if ever, have water at the surface. We really wanted to avoid that type of situation. We wanted to avoid the potential for any issues like that. We also do think that there's the potential to cover. You could essentially just put holes where the plants are coming out. So there's potential to cover this type of system and still have it perform in a very similar way. So anyway, I think there's some options, but I think it's a good point, and I think that we'll see what DOH thinks about it and what may be appropriate.
Yeah, and that's a good distinction. We kind of hesitate to use a constructed wetland because people get the idea that there is liquids there, and it's all underground generally. So we need to kind of have a refinement of that, even though it fits in that category. Technically, it is different. So yeah, and the other thing is, this is a step in between a septic tank and a leach field. So like an ATU, this would serve to denitrify and get rid of the harmful bacteria, but it's a line system as we have it so far, with the results being even better than ATUs. And this is based on our research here, but also 10 years of Stony Brook University's research on the East Coast, based on their nitrogen reducing biofilters, which are very similar. They are performing better than ATUs, but the advantage is you don't have the electrical cost for the air pumps, and then you don't have the maintenance. And so we think this would be a really good system, for that. What we're going to be trying to argue for is that the effluent that comes from that system is so good. Right now, DOH just by regular regulations is saying, no, you need a full-size leach field after that. And we're saying, look, the effluent that comes out is super high quality. So for ATUs and these kind of systems, there should be a much greater reduced leach field, because a lot of lots in Hawaii are just not going to have enough space for the full leach field. So that's one of the regulation changes that we'll be requesting from Department of Health, and would love your support on. And Sylvia, I wanted to ask a question, and then Martha will come to you if that sounds good.
Yeah. And what you just said about the size of the leach field, I guess that's the critical item, because
Okay, let me repeat that because we can barely hear you, Sylvia. Is this like an additional step in a traditional septic system in between the tank and leach field? Or is the entire system different in terms of tank and leach field? So, as Yoka said, it's in between the tank and the leach field. And we're hoping to, get a smaller size leach field because the effluent quality is so high coming out the other end. All right,
Yeah,
Martha.
for example,
Yeah, go ahead.
Pennsylvania allows, for systems that are NSF 245 certified, they allow the leach field to be reduced by 1/3.
Which makes a huge difference in size and costs for homeowners. Yeah. Martha, do you want to go?
Yeah, that was actually my question. If the objective was to scale down, the land needed to have a system. Yeah, okay.
Yeah.
Thank you.
So that'll be another hugely valuable thing that we can try to push for, in getting some regulation changes. Yeah.
Yeah, that's also why we're measuring evapotranspiration. We've, calculated it and estimated it, but we're actually measuring it as well, in sort of the mature system. How much evapotranspiration will the system do? We think it's pretty significant.
Yeah, and again, that's another regulation that currently DOH doesn't allow for reduced, if you have reduced volume through evapotranspiration. And so we're really pushing for that. Say, if we have hard data that shows it reduces by so much, maybe just give us a little bit less, size of the leach field, since the volume coming will be smaller. Nancy says, we have challenges on Hawaiian homelands with cost, lot size, and maintenance. This seems like a good way to address all three and more. Excellent.
Oh, also cost to operate. If it doesn't use electricity, that's really helpful for our homesteaders too. So yeah, Very impressive.
Cool. Thank you. We're working with Department of Hawaiian Homelands to partner to also try to get some of these on Hawaiian homestead lands, but also to train more Native Hawaiians in technologies like this, because this is going to become such a big field with 88,000 cesspools to convert in the next 30 years. We need to convert more than 3,000 a year, and we're converting about 150 a year right now. So the workforce is going to have to expand dramatically. And so we think this is going to be one of the great tools in our toolkit to do that. Other questions or suggestions, if you have ideas of ways to market this?
I have a little bit of a brainstorming question on, so when we install one of these at a home site, what parameters would people be most interested in seeing the results of, in addition to the kind of standard TSS, BOD, nutrients? Are there any other like really high priority parameters to measure?
I would be interested in knowing what the maintenance is like the cleaning. How long does the cleaning take? The flushing, the periodicity of that function, and how much time is consumed, and chemicals or, media or whatever.
Yeah. Paul or Yoko, do you want to take that?
I was going to let maybe Danny speak on that, because she got to witness the system in action, 5 days a week, and maybe just comment on any maintenance that had to be done.
Unfortunately, Danny had class, so she's such a super student. She came, gave the presentation, and then jotted off to her next class.
So one of the things that Danny said in her presentation was that it didn't require any maintenance. That, and I'm not saying that. I think the cutting back the vetiver maybe to about 18 inches to 18 to 24 inches once a year, things like that probably would be useful to do. We installed one of these at a hotel in Puerto Rico, a 27-room hotel. And so they maintain it much like they do with their other landscaping. And we also planted that one with a lot of hibiscus flowers, and then put some palm trees and stuff next to it. And so they really see it as an amenity in their landscape.
Yeah. And so, yeah, cutting back, like if it's vetiver grass, it grows pretty fast. So occasionally you might have to cut that back, but really kind of low maintenance. Other parameters that you'd be interested in?
Well, the homeowners obviously are going to be interested in odors. And I would think a demonstration along the lines of what Revolusun has done to show people what the technology looks like when installed, so that people can come see it for themselves and see that there are no odors, and see how it looks on the property. Might be a good idea.
Yeah. Yes, we have a picture that maybe we can, Paul or Yoko can pull up, of the one in Puerto Rico, which is quite lovely. And I guess one of the question, I don't know of any odors, except we were testing at the East Honolulu wastewater treatment plant, which is just pervasive with odors as soon as you come on the property. So Paul, in previous installations, was odor an issue?
No, it's not. It hasn't been an issue. So I think partially because the wastewater is, again, it's under 20 inches of sand. So or it moves quickly through that sand. And also, I think you have the vegetation and, you know, the leaf litter and that sort of thing. And it really, we also use some biochar in these systems as well. So all those things kind of cut down on odors.
Also, I'd be happy to have some, you know, open days for people to check out the system at my place once that's installed. You know, if we can schedule it ahead of time, I'd be happy to have people by to see it.
Yeah, that's a great idea, Christina, thanks. So this is the installation in Puerto Rico, right, Paul?
You're muted.
Unmute. Yeah, that's the installation in Puerto Rico. And again, that's for a 27 room hotel. And they even have a small restaurant there as well. And that's performed really well. I think it's been in the ground around 3 years now. So
That's great. It looks like they just trimmed the vetiver grass back a little bit.
and at first the iguanas were eating our hibiscus plants, so we had to put little things around the hibiscus plants.
Mhm. Yeah.
The invasive iguanas, that is.
And is this system lined or unlined?
Lined.
Very cool. And the black things in the back, are those the septic tanks?
No, the right under that, see the concrete under the black
Yeah.
tanks? That's the septic tank. And we put this on to their existing septic tank that was essentially surcharging and overflowing into then actually going to, there's a bay right off to the left. And there was, we found this sort of doing an illicit discharge survey. We found really high bacteria levels in the adjacent water. And then we realized that their septic system / cesspool was failing. And then we sort of retrofitted this system onto it. So. And very often we're not seeing any discharge from this system, particularly during normal usage. And then, during higher usage, it is going into the infiltration gallery essentially, and, going into the ground. But we were seeing like 50 to 60% removal of nitrogen and phosphorus in those. So the system that we've built in Honolulu definitely had some refinements, and we're seeing improved, we're seeing higher removal rates of nitrogen.
Thanks for sharing that, Paul. And one question I'd like to ask the group is, we have kind of two models for this, and one is with the vegetation, as you can see above in this and the one we presented. And then one might be, with just underground, where like a traditional system would be underground where you wouldn't see it. And I'd love to hear, from this group, maybe putting it in the chat. And if anybody wants to talk about like what you'd prefer. Any thoughts on that? Just one at a time, please. Yeah,
Can you say one more time, prefer between what?
Yeah, so one version would have the vetiver grass and some indigenous plants. Like Christina wants that on her property because she likes the idea of having that to kind of showcase, here's what we're doing, and this is a really cool nature-based system. But then we imagine there are other people that might be like, oh, I want to flush and forget. I don't want even people to know it's there. So just kind of an informal survey on this call, how many people would like it to have the plants, which adds the additional treatment and evapotranspiration, but also beauty. Maybe show of hands. Yeah. Okay. And then how many would not? Like, and Palani, you've installed a number of these things. How many do you think would prefer not to have it seen? And thank you for your comments in the chat.
What's the difference in the efficacy when you remove the plants? Is it significant?
Yeah.
I think what will be different is we're going to miss the evapotranspiration component. And also with all the vetiver grass in these systems, there's also a significant carbon sequestration that happens as well. So I think that those are the two things. It would be, and I mean, I think evapotranspiration in a mature system, that system is only 6 or 7 months old. And I think evapotranspiration could be somewhere between 30 and 50%. We're still waiting on the numbers, but we actually, when we designed this, we had to design it in a way that we didn't want the vetiver grass to absorb all the water, because we would have failed the test, because there would have been nothing to monitor coming out of it. So I also think it's possible to engineer these systems so that they're zero discharge systems, which I think would really be amazing for the environment. I even think that this system, for a normal, family using these systems, I think that, the engineering standards for septic systems and wastewater systems are sort of to overbuild the system. So I think that generally a lot of these systems, I think, are going to be zero discharge systems functionally, say 90% of the time, except when you have a Super Bowl party and everybody's, parked down the block and, something like that. And a lot of people are at your house.
Yeah. And, as Rebecca and Nancy said in the chat, the plants are fabulous. It's an opportunity to educate people about the issue, which is also really important. We really need to make people aware of this. But then, I think as Sylvia said, I think there are, a lot of people who are, clients that are just going to say, hey, I don't want the maintenance. I don't want to look at it, and are going to want something without. So I think we'll have both. Yeah. So even though DOH doesn't allow for the leach field reduction right now, we're really hoping they will. And so without the plants, you wouldn't get that leach field reduction. Most likely, yeah. And Martha, I think what was the size of the leach field again?
Size of leach field?
Oh, sorry, size of this.
6 by 14.
6 by 14, yeah.
6 by 14.
Yeah, for a 3-bedroom house. Yeah. So, the Big Island has a lot of space, so bigger lot sizes in a lot of areas, which is good. So we think it's great for that. Soil, finding the appropriate soil and sand is challenging, so those are some of the issues on the Big Island. But, the ideal thing, again, is if we can prove to DOH, and we, hope to have that data soon, that there's dramatic reduction through evapotranspiration. One goal, the kind of holy grail down the line, would be have this between the house and the cesspool. So, and then have the cesspool for the overflow amount, because at that point, you've cleaned out the cesspool, and then what's going into the cesspool would be really, really clean effluent. And so that would be your drainage. especially for steep lots or lots that don't have enough size for a full leach field, just to repurpose that cesspool for drainage is the ultimate goal, because that will cut down costs dramatically. Yoko, did you want to say something?
No, I was just waving goodbye to Becca.
Okay, thanks for joining us, Rebecca.
Aloha, everyone. You're fantastic. Take care.
Thank you. Aloha.
Talk soon. Bye.
Okay, bye. And as we kind of wrap up here, as I mentioned, we have a USDA TAT grant with Ridge-to-Reef, and we're going to be doing some demonstrations. So if you're interested, let us know and we can keep you in the loop for when we do these sessions, these training sessions. And then we also have a list of regulations that we're really trying to gather support for to DOH, really common sense things that are based on what other states do. Yoko put a lot of time in researching successful, regulations in other states. So we can share that in the chat if you want to check that out, an abbreviated form, or just help us. We're always looking for volunteers that can help us with the bills that we have coming up for the next legislative session and for regulation changes that are going to bring down the cost dramatically of these conversions. So does anybody want to see that in the chat? We can put a link if you're interested, or a PDF. All right, yeah, let's go ahead and put that in there, Yoko. And then are there any, yeah, it's at the bottom of the chat, you can see. Any topics that you would like presentations on coming up? We generally have these the third Wednesday of the month, but we can be flexible, especially with the holidays coming up. We'd like to do at least one more of these before the holidays. And so Christina has a presentation on water quality info coming up at some point. But if you like these kind of new technologies that are going to be kind of game changers, that are lower cost, yeah, stay tuned and make sure that you're on our mailing list. I think most of you are, because you're here. And then if you also have any suggestions of things you want to learn more about, feel free to let us know. We were thinking about doing a policy brief overview of the bills that would be supporting, maybe in January, the third Wednesday in January, so that we can kind of, by then we might do it in February, because then we'll have bill numbers and we can, tell you when hearings are to get support for certain bills we're trying to pass. All right, Christina says a concern of converting cesspools to seepage pit that may DOH brought up as structural integrity. Many cesspools would need to be retrofit with concrete wings for safety purposes, but it still saves space. But it can be expensive.
That's
Yes.
right.
Nancy says, more please, more affordable, no low cost maintenance. I think that's the refrain that we'll be hearing a lot more of. That's what everybody is looking for as we try to solve this problem. Well, any final questions or announcements about upcoming events that you want to share? All right, hearing none, we will bring this to a close. Thank you so much for taking the time on your busy afternoons to hear the good news about this new system. And feel free, if you have any suggestions, ideas, or want to get involved, please email us. It's easy to remember, info@vicleanwater.org, which we'll put in the chat, but most of you have our emails. And we want to, even though Danny's not here, thank you to Danny, and a special thanks to Paul for staying up late on the East Coast and for bringing this technology to Hawaii. It's been great working with another nonprofit that's really doing great work on this issue.
Thanks. Happy to be here. Thanks, everyone.
Okay.
Thank you all.
Thank you all.
Aloha.
Have a great afternoon.
Aloha.
Bye.